So your test 2 will cover LO3. Today we look at lots of phase diagram. This diagram a lot of things, and then then we go into properties of polymer and ceramic. This one will be in your test 2. So your final exam will be question 1, question 2, question 3, question 4, and 5. Okay. We already done your test 1. I haven't marked. Test assignment will release next week. Lab report you submit week 12. Now we are in week 9. So you have 2 more weeks to submit your report. Final exam will be 60%. Okay. So chapter 9, we'll look at graph. We look at graph. So pay attention to how you extract data from the graph. So during your test 2 and also your final exam, there will be one additional graph attached at the last page of the exam paper. You need to detach it and then stapler together with the answer script. Okay, yeah. All right, so we start with a very simple pure constant, pure substance. So this will be the first graph that you see. Of course, I won't use this graph in your test, but it's a good start. So what does this graph tell you? How you read this graph? So y-axis is the temperature, x-axis is the composition. In one of the chapter, we did study how to calculate the weight percentage. So the x-axis is from 0 to 100. So here you have 2 components. One is sugar and water. So this graph is for sugar solution. So as we go deeper, you only see one element here, where we mix pure metal with the other element. So here you have sugar, 0 sugar percent until 100% sugar. So means at this point, there's no sugar, and at the other end is 100% sugar. Then other component is water. Okay, so sugar is very popular in chemical and chemistry because it's available and it's cheap. So sugar will be CHO. C will be 12, 22, and 11. Okay, then again, all graph, be careful on the unit. This one Celsius on the left-hand side, Fahrenheit on the right-hand side. Some graph, Fahrenheit will be on the left, Celsius will be on the right. So read carefully. When we go into chapter 9, we're more focusing on the phase and the composition inside the metal at a certain temperature. So first technical word, we call it solubility limit. Solubility limit, in this graph, you have one red line here, solubility limit. What does it mean? It means that is the maximum concentration of solid atoms that can dissolve in the solvent, right, to form a solid solution. So as you can see on the graph, there's 2 regions there. On the left is liquid, or we call it syrup, liquid solution. On the right-hand side, beside of the red line, is solution plus solid sugar. So on this line, this red line, it means that it decides whether if that, for example, 20 degrees C at this red line, okay, what does it mean? Right. So, for example, we look at intersection. For example, 20 degrees C, what will you have if you mix sugar with water? At 20 degrees C, you can see solubility limit reached to the maximum you have will be about 60, this one 70, so it's about 60 plus percent. It's about 65%. To me, it's more like 60, what, 63, about that, 65. But so it tells you that at 20 degrees C, if you're referring to the solubility limit line, you can get a solution with 65 or 63% of sugar and water, right? So this line also tell you that the system is in equilibrium, means stable. So it keeps stable at a certain percentage. So at 20 degrees C, you can find the composition of syrup will be at 65% weight percentage of sugar and 35% of water. So as we go deeper, we will look at metals. So later you need to mention how many percent metal A plus how many percent metal B. So later your answer will be have how many percentage of component A dash how many percent component B. We only look at two elements, two elements. So the first word is solubility limit. Okay, solubility limit. Okay, so same if you go to other temperature also. Next, we look at phrases. Phrases in physics, you know, if you look at water, water have solid, liquid, and gas. What make them change phases? Because of energy. What is the normal normal parameter we use is temperature. Temperature means energy, right? So if you increase temperature or you give more energy, it will change from solid to liquid, from liquid to gas. And you remove energy, you can form gas back to liquid, and remove further energy, you form solid. Okay. So phase is a region where have a uniform structure, properties, and composition, and separate by boundaries. So phase is it depends on temperature and pressure. Okay. So just now, the graph just now is solubility limit. The next phrase, next term is called phase. So you have solid, liquid, and vapor phases. Okay. So if you see single phase system means homogeneous. So if heterogeneous means you have more than two phases. It appear at two phases. So if so what are the homogeneous single phase? Single phase, it means if you look at sugar just now, on the left-hand side of the graph, this region is called single phase region. Because all these, you only have liquid. But on the right-hand side, you have liquid and solid. This side is heterogeneous region. So it means that more than two or more phases in that region. Okay, so homogeneous and mixture system or heterogeneous. So these are the two words that you try to describe the condition of that element at certain temperature when you refer to graph. So it will tell you, okay, given you so and so, the process go through a certain temperature and predict what you have, how many percentage and what phase. Okay, so it's either in liquid, in gas, solid, or is it homogeneous or heterogeneous? Okay, so the next one, just now is syrup. Now we go into water. We will try to combine what we learned in sugar, water, we bring into metal later on. So we try to build the tempo. So on the graph here, again, on the left-hand side is the pressure. It's a pressure versus temperature. Okay, so at a certain temperature, at a certain phase, certain temperature, a certain pressure, you will have different phases for water. So here you have three blue lines. We have three blue lines, and the area represent phases. First region on the left is solid phases. In the middle is called liquid. At the bottom is called vapor. Okay, so this is called phase diagram, which is important for your incoming assessment and also your final exam. Again, you will see one extra graph at the back of the question paper, you need to detach it, staple together with the answer sheet. So if you do not attach, means no marks for that question, especially question 3 or question 4 or question 3. It's a compulsory question. It's a compulsory question. If you don't attach or you forget to attach, means 0 marks for that. Because all the answers are referred to that graph. Okay, so for example, on the graph, you will see one point you call triple point. So triple point means at that point you have coaxis of 3 phases. You have solid, liquid, vapor at that particular point. Okay, so triple point, this is for water. Later you will see metals. Metal also you will see triple point. Okay, so let's say if the point fall on this point, it means the certain temperature and pressure will give you solid. If the point fall on this blue line, it means what? It means at equilibrium boundaries, it can be either solid, it can be either liquid. If it's fall on blue line, it can be solid, it can be liquid because it's at equilibrium. So it's like you strip a little bit pressure, it will flip to solid. Strip a little bit pressure, you flip to liquid. So on the line, it is, you need to read the 2 phrases on the left and right. For example, I pick this point. This point, the object or the phrases you have will be liquid and vapor together on the blue line. But at this point, triple point, it means it exists 3, solid, liquid, and vapor. At what temperature? You read down. So here at almost 0 degree. At what pressure is about here? You read from the graph. Okay, so it's important you train yourself to look at the graph and then understand what you have. So for here, you have freezing line, you have vaporization line, and so on. So means vaporization line means past this line become vapor, past this line it become liquid, past this line become solid. Okay. So the rest you read now. The rest you read. This one you learn in your physics already. Now we look into our main target or main topic, which is pure metals. First, we look at iron first, which is Fe. So here you look at the graph, PT graph, or T. P means pressure, T means temperature, PT graph. We give you phase diagram. So you look at the temperature, you look at the pressure, and then inside here, all the graph you will see phases. You will see vapor, you will see liquid, and so on. So means vapor means this blue line on the left-hand side of this area will be in vapor. Here, right-hand side of the graph will be in liquid. So means if you want to make metals behave in a vapor form or gas form, you boil, you give a certain pressure and temperature, you will see your metals in the vapor form. So, and here, for example, here you see triple points, right? This here, triple point, triple point, triple point. Now, what does it mean? Here you have different types of forum here. You have delta, you have gamma, you have alpha. So below 910 degrees C, you will form alpha forum. Above 910 and 1394 Celsius, you will get gamma forum in FCC form. This one BCC form. Now try to link what you learned in chapter 1, chapter 2, FCC, BCC. So the question from chapter 9, it can link back to chapter 1, chapter 2 question. So you can read from graph, you get from the phrase, then you calculate maybe the A, or you draw the crystal structures, and then how you do the strengthening, how you fill in the alien, how you do alloy. Okay, so, and then between 1394 and 1538, you get delta ferrum. Above 1538, you get liquid. Okay, you get a liquid ion, liquid Fe. You don't know the phase. You want to change the phase, you drop the temperature. Okay, now for example, so there are three separate distinct on this graph. So you have solid phases, so it is here. Here is solid phases. You have alpha, gamma, and delta. So it means this line, 1538 is your melting temperature. Okay, it's a melting temperature. So after you pass this one, you will get liquid already. Okay, so alpha, BCC, delta, and so on. All right. So here, this line here. Again, this line is equilibrium line. So at equilibrium line means it exists the left and the top and bottom. Means is, or if you stand on the line, it's just on your left, right. So if you stand on this line at 1 atmosphere, you will get gamma and alpha solid ion. Huh? Okay. So at what temperature? At 910. Okay. So if you increase the temperature, you will change alpha into gamma. This is single phase gamma axis. Okay. Then below you get single phase alpha. So single phase, single phase. Okay. So there will be three different phase coexist at triple points. So here, here, and here. If you meet at this point, what do you get? If you stand at this point, you look around you. So what are you have? You have vapor, you have liquid, and you have delta ferrum. This one. So you get the first point here. Second point, if you stand here, what you get? You get vapor, you get delta, and you get gamma. You don't have liquid. At this point, you don't have liquid. If you answer, you give liquid, means wrong answer. So be specific on the location. How we ask you, we will give you point A, point B, point C. You write the phrases that exist in that particular region. So it will give you like 5 points on the graph. Then you write what you have. For example, I pick this point. You write liquid, vapor, and delta. If you write gamma, alpha means wrong already. Okay, if I pick this point, you have vapor, you have gamma, you have alpha. If you write delta, means wrong already. Delta, if you want to get delta, you should get temperature should be 1394, then only you have delta. Okay. And so on. So just be careful on the location on the graph. Okay. Then once you know how to pinpoint the phrase on the TP graph, then we start to do calculation already. Calculation was given by Gibbs phrase rules. Gibbs phrase rules, it gives you P plus F equal to C plus 2. What's this? P is number of phrase. F is degree of freedom. C is number of component in the system. So P, F, C plus 2. Okay, so this equation is called Gibson phrase rules. So when you need to use this one is when you're given a certain parameter. So I'll give you one example later. Okay, so let's look at water first. Water phase diagram. So this is phase diagram. So at triple point here, at triple point, three phases coexist, and since there is one component in the system, means inside this phase diagram we only see water. So your equation, right? P is number of phase. So on this graph you have triple point here. You have three phases. Number of component on this graph you only see one element, water. So how many phase? You put in P plus F equals C plus 2. There's one missing. Degree of freedom is missing. You do calculation, how many degree of freedom? How many degree of freedom? 0. There's no degree of freedom in the triple point here. Okay. So this call, if you get F equals 0, means it's fixed there already. Okay, the rest you read, huh? Okay. Triple point, and some textbook they also use invariance point. Some textbook, okay. But in our class, I rarely use invariant point. I will straight away use triple point. Okay. So next, use the same equation again. So consider next point along liquid solid freezing point. Liquid solid. Okay. So how many points? Right? How many points? So liquid and liquid solid. Sorry, liquid and solid is this point, this line, right? So based on the Gibbs phase rules, you know that component is 1 because only water. C is 1. How many phase? 2 phase. So 2. Then C is 1. So 3, 1, 3, 2. Freedom is 1. So you only have one freedom, 1 degree of freedom. Okay. So 1 degree of freedom. So it means one variable, temperature or pressure, it can change independently and still maintain a system with 2 coexist phases. So if you want to work on this line, so you can either change temperature or pressure to work on this line. Okay. Okay. So this one is an application. So if you fix the pressure, then there's only one temperature that you can use if you want to work on this line. If you're given pressure, then you can only work on temperature. If you're given temperature, there's only one point temperature pressure that you can use to get this solid freezing line or freezing line, right? Solid liquid line, phase line. So we are looking at water now. So it will be more complex when we move into metals later. So in third case, let's pick one single phase. So any point around this one phase area. So this is solid, this is liquid, this is vapor, this is single phase area. So how many lines we have? If you pick any line here. So C is 1. Number of phase is what? 1. Right? So if you pick any area here, component means only one element, water. And number of phases, 1. Other solid, only 1. Liquid also 1. Vapor also 1. So degree of freedom means 2. Means you can change pressure and temperature together to get that particular single phase. Understand? 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 Cannot get it? Okay. Okay. Now, this single phase is mean what? Solid. Either is solid, either is liquid, or either is vapor. So it's either you pick 1 point, 1 point here, 1 point here, 1 point here. You only look at, okay, solid means solid, liquid means liquid, vapor means vapor. So if you use this equation, you know that C is 1 because only water. Then phase is only one phase here, solid. So 1. Then degree of freedom is 2, right? Correct or not? This is C is 1, 1 plus 2 is 3. Then phase is 1, so freedom is 2. Freedom is 2, not 3. 2. What mean by freedom? Freedom means how many parameters that you can play with to get that particular phase. For example, how you get solid? You can play with a range of temperature and range of pressure to get any point on this area. Same with liquid. You can play with any temperature and pressure to get this area. Same with vapor. Okay, I switch back the previous slides. Now, if we only look at okay, this one, liquid solid curve. Liquid solid curve, with this one. So along this line, how many phases it can exist? 2 phases. It can either exist solid or liquid. There are two kind of member can work on here. So this equation, it become, this is 1, this is 2. So degree of freedom is 1. So you only can play with 1 parameter. Means you can either fix 1, then you change another 1. Degree of freedom means you only can change 1. You need to fix 1. Yeah. What about triple point? What about triple point? Triple point 0 means you cannot change. There's no parameter you can play to change the phrase. Triple point fixed already. Means there's no freedom for you to play. There's one exact value for that phrase. That's there. Okay. So this is first steps normally when you do analysis. Okay, how many freedom you have? If 0, then is normally it's triple point or 4 point or 2 phrase point, something like that. 2 phrase normally is 1. 1. Okay. 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 Is on the freedom. Okay, this equation also we can test you. We'll give you a scenario. So we'll give you for example 2 metals and so on. Then you find how many phrases that can be there. I give you a triple point. Then how many freedom you have? Okay, this is only for water for this one. Okay. The rest you read. The rest you read. Okay, next is on the cooling curve. Just now is on the temperature. You see one more is the metal forum. Okay. Continue with the graph. Okay. Next is the cooling curve with its temperature and time. So temperature and time. Temperature on the left. You know, as you increase the height of the temperature means more temperature, higher temperature. If you move to the right of the time means longer time you have. So this is for the pure metal, especially you see pouring temperature means is for casting process. So when you want to do casting, you want to make sure you works in between A and B, meaning this is liquid phase. Over here is liquid phase, and then liquid plus solid, and this is solid phase. Okay. So if you, for example, A to B is a cooling of liquid, B is solidification, begin. When you do freezing temperature, you will maintain. Solidification ends. This is N, and then D, cooling of solid. So this is on the molten. I rarely use this graph. Okay. This is just for your reading lah. It's for reading. And just I need to highlight again is that the line that you see on the phase diagram, they are called equilibrium, means balance. Equilibrium. Equilibrium. The rest you read. The rest you read. Okay. Another one is called temperature time also, but this one is for ion at one temperature, one pressure, right? So at 1 atm, you see it will, when you cool down, it will change from liquid at 1538. Then it will flip to delta, drop to gamma, drop to alpha. Okay, if drop from liquid, so inside liquid, you have a, we don't know the phrase because it's very hard to identify. We only know that it's in liquid. Then once we drop, then we can see, we can detect with the microscope. Then we know, okay, we are getting delta at between 1538 and 1394. You'll detect delta ion. Then we drop temperature between 1394 and 900 something, you get gamma. And you drop below 900, you get alpha. So, okay. This graph also you won't see in the test because it's just a very simple. This one you get if you do research. This is from your raw data. Okay. Now this is more interesting. So you will get binary alloy. Binary, you see the Bi means 2. Bi means 2. So you have 2 component alloy. Then you will see something like this. So for example, copper in nickel. So you will see something like this, or carbon in ferrum. So you call very, very small dot here. There are 2 types of strengthening mechanism. You still remember? One is substitutional, you substitute, or insertatio, is fixed inside the space. There are 2, substitutional and insertational strengthening mechanism. All right. Okay. The rest you read, because they are not that part. Okay. This one, substitutional and insertional, normally they will come out in the crystal structure question. They ask you to find the gap between the 2 spheres. Okay. Okay. Then we will start to introduce you one more for binary system. It's called HR solid solubility rules. HR rules. We need to look at when you want to use these rules, you need to consider all this. I'll give you all. Okay, you need to consider this all. And this slide is important. This slide is important. Okay, so when you need to use the solubility rules or you do the strengthening, you put in substitutional or insertatio. First, you look at the size of atom. It cannot more than 15%, meaning you take the original atom, the host, and the alloying element. The 2 cannot be more than 50%, means the size cannot be more than 50%. And the elements should not form compound, means they cannot dilute each other. For example, NaCl cannot be used. NaCl is charges, so it cannot. So it cannot form compound. So alloy, you don't choose those high reactive metals because they will exchange electron. So for example, this one is copper in nickel, still okay. Right. The third one, crystal structures must be the same, meaning crystal structure means the box, right? The cube that you draw. So crystal structure must be same, because if not same, it's like you are doing the Lego, right? If not able to fit inside the space, because you have hole, you have the defect, So when you have defect, you must like doing Lego, you must slot inside. So if the crystal structure not same, it's very hard to put inside there, right? So if like a square means you need to put inside square. If it's circle, then circle. Triangular, then triangular. The elements should have the same valence. Same valence means outside or on the periodic table is where do you look for variance? The vertical column. Okay, group 1, group 2, group 3, group 4, group 5, group 6, group 7. If you group 1 means what? Only one electron outside. 2 means 2 electron outside. So why they must have same valence? If you have group 1 and group 7 together, they do not meet number 2. Group 1 and group 7, they will form compound. So cannot. So they must have same valence. Yeah, these 4 points. Size of atoms should not form compound. Crystal structure must be the same. And element should have the same variance. You can group 0.4 and 0.2 together. Okay. Now we start to be a bit more serious because this one is very popular in assessment because we are looking at phase diagram for metals. Okay. So before you look into the graph, look carefully the title of the graph or the y-axis, especially the x-axis. The x-axis will be copper. You see copper and nickel. You see left-hand side and right-hand side. Earlier class, you see 2 rows here for the sugar. But now, on the metals, you only see 1 element on the left-hand side, 1 element on the right-hand side, 1 on the left, 1 on the right. What mean by this number? If it fall on the left-hand side, we are looking at copper. Sorry, 100% copper. Means 0% nickel. Okay, 0 means 0 or 100%. So if copper over here means copper 0%. Sorry, let me see. Read, 8% nickel. Yeah, okay, correct. So if you look at here, 100% nickel, then this one 100% copper. So here, my practice, I always write at the right-hand side first. I write how many percent of that element. So if this point is 100%, means if I reduce this one, I will get 0% nickel here. Then this graph is combination of copper and nickel. If I land on this point, 50%, means 50% copper, 50% nickel. If I land on here, means 90% nickel, 10% copper. The percentage must be 100%. Okay, makes sense, huh? So on the graph, first thing you look is x-axis. Be confident that which is 100%. Moving to the right, what is 100%? In this case, right nickel is 100%. Okay. Then temperature. Minimum, maximum. And then, of course, you won't see A in the test. I'll remove this one. Okay. Then what else? Next, you look at the phrase. Liquid, solid. Liquid, solid, and then you see the L here. L plus alpha. What does it mean? L means liquid. Because this line, normally we won't remove this line. So this line is called liquidus line, means liquid line. So past this line, you'll get liquid plus alpha, means nickel phrases in alpha. Then after this line is called solid line. After this line becomes solid. Solution alpha. Okay, so it's very direct, right? So all the information there is very direct. For example, if I pick this point, how do I know this point at 1300 degrees C? what are the element that I have? So your answer, if I put the point here, your answer will be, you move down here, you get 45%. 45% of what? Nickel. And you must put percentage, 45% percentage of Ni. Then I pick this line. This line you move down is about 58% weight percentage of what? You read the right hand side, nickel. Okay. Then later we'll do calculation on this line. We are very interested to find liquid to solid region, especially on the graph. This one, 1300 degrees C. You have two lines. One is on liquid, one is on solid. We are more interested in this line when you do analysis later. When you do analysis later, this line is called tie line, right? And we will work out a solution. This one, we'll work out a calculation later. How we get 53%? There's one equation to calculate 53%. So when in the test or in the final exam, you won't see this line, you won't see this line, you won't see this line. I will also remove this line. I will shift this line up or down, then you do calculation on the solid and liquid, then find the point. Okay, I will show you how. So this is a binary phase diagram. It means you have two elements there. In this graph, you have nickel and copper. Okay. And binary phase diagram, their usage is to predict. This is also how we test you. You will see predict the word in the question later. Predict the phase transformation at a certain point, at a certain temperature, what you get. Okay. So again, which may have equilibrium and non-equilibrium character. What I mean by equilibrium? Equilibrium means falling on the blue line. Anything on the blue line, either is liquid or solid, is called equilibrium. Those space, empty space, is called non-equilibrium. Okay, we start some calculation. So I enlarged the graph just now. Okay. So this one I already explained. On the top is liquid, on the bottom is solid. At the region, you have liquid and solid. Liquid and solid. So here, solid here is solid solution alpha. So okay. Okay, again, you do the calculation using Gibbs rules. So you find the freedom, right? Freedom equal to C minus P plus 1, right? So how many freedom you have? How many C? What is the C value? 2. So 2. What is how many phase? It depends on the line or location. Okay. So if I pick one point, at melting point of the pure component. Melting point means what? This line or this line? At melting point means it change into liquid one, correct? Start to change into liquid one. So the component is at melting point of pure component. Pure component. Okay, at here. Mean here is 100% copper. Here is 100% nickel. So at this point, you only have one. Right. Between here, you have two. But here, you only have one component. So number of phase here is either liquid or solid. Then degree of freedom will be 0. Okay, so at this point, zero freedom. So, okay. Okay. The next one will be single phase, liquid or solid, right? So component is 2, because inside here, solid here, you have either copper or nickel. Your liquid also have either copper or nickel, so component 2. Number of phase is 1, is either solid or either liquid. If you look at this region, then your P is 1. If you look at this one, liquid, then its P is 1. If you look at this region, 2 component here. You look at this region, also 2 component. Okay. Then degree of freedom will be 2. Degree of freedom means if you want to look at this area, how many parameters you can play with? You can play with 2 parameters. You can play with temperature and percentage of mixture. All right. Because on this graph, you only can see temperature and weight percentage. Okay. For composition. So the rest is same lah. The rest is same. Okay. So for point A is about 1050 Celsius. So at this point is 20% nickel. 20% nickel. This is alloy. So at this point, you will have 20% nickel and 80% copper. Here, you have high strength and elasticity of 4 kPa and so on. Right. For this one, I rarely ask you about this one. I will ask you what are the component you have over there, and then some calculation on here. Later, we will have one calculation over here. So the rest is still using the Gibbs rules. All right. I don't need to go deep into this one. All right. So binary, Gibbs rules in 2 phrases. 2 phrases is maybe this region. Right? This is 2 region phrase. So these 2 region, you have 2 component. Phrases, you have 2. So resulting degree freedom of 1. So although here, to here, you need to fix 1 and then play with another one. Okay, to have this region, you fix 1, play with another one, because degree of freedom is 1. Okay. So for example, 53%. 53% of if you fix the concentration, or fix the concentration. If you fix 53% nickel and 47% copper, you can only play with temperature. Okay. Okay. All right. This is another graph that you might see, but I won't use this one. So temperature time, you have pure copper and so on. This one nickel and so on. The rest you read. Okay, we will have a short break. Later, we will look at level rules that help you to calculate something inside the 2 point here. Okay, we have a short break. 10 minutes. We continue 3:05.